In optics, we'll learn about the basics first, then after we will discuss about the reflection of the light at different surfaces. First of all, we have to understand what is the optics is. Simply, optics is the study of light. Optics is the study of light. Light, it is one of the forms of energy, you know that. We study the optics in two ways. We are classifying the optics into two types. One is ray optics and second one is physical optics. Okay. This ray optics is also known as geometrical optics. Okay. And this one also known as the wave optics. Here, when we are studying about the optics, particularly in ray optics, we learn about the properties like reflection, the refraction. These two are explained by geometrical method. If you go with the physical optics, and here we learn about interference, second is diffraction, or you can say it is a diffraction, and third is polarization. Okay, these are the two branches of optics. One is the ray optics and second is the physical optics, or we can call it as the wave optics. The name of the ray optics is geometrical optics, and here we learn about reflection and refraction. First of all, we have to understand what is meant by reflection. Reflection is a daily phenomenon. We observe the phenomenon of the reflection in various cases. You are able to watch me, it is because of reflection of light. I am watching you and we are watching the things which are around because of the reflection of the light. And what is the reflection of light? It's nothing but bouncing back of the light when it is incident on any surface, irrespective of shape, is a bouncing back of the light. We can understand this phenomenon very easily by taking a mirror. What's a mirror is, you have to understand. What's a mirror? Mirror is a transparent substance which is coated at one side. It's a transparent substance which is coated at one side is known as mirror. In early classes, you already learned about what is the transparent or what is the translucent and what is the opaque substance. What's transparent? Which allows the light to pass through it. It's the optical medium. Translucent, it partially allows the passage of light through it. And third one is the what? Opaque. It doesn't allow the passage of light through it. There are so many examples around. For transparent, you can take any optical medium. Air is the transparent, it is optical medium. Similarly, if you take the glass slab, which is not polished at one side, that means which is not coated. Thin glass is a transparent. Water up to some level is transparent, and thin polythene sheets, these are all the transparent. If you go with the translucent, you know that oil paper is one of the translucent substances. The same, what? Window panes. Here in homes we use the window panes. You can see through it, but you cannot recognize the thing completely, which is another side. And third one, the opaque substance or body. Most of the solids, walls, all these things are what? Opaque substances. It's a classification. Then after, we have to talk about the laws of reflection. Here, to understand the things very easily, we have to go with the basics. Here I already told you, a mirror is a transparent substance which is coated at one side. Around us, we see so many mirrors. Generally, we use the mirror to watch ourselves. Here, if you stand in front of the mirror, you will see yourself only. What you are, you look same. But some cases, what could happen? You appear to be bigger or the smaller. Those mirrors in which the things appear to be smaller or bigger are known as the spherical mirrors, or we can say curved mirrors. Generally, these kind of mirrors can be seen in rear view mirrors of the vehicles. If you watch your parents' vehicles, either it is a car or the bike, they have provided with the rear view, side view mirrors. Here if you see yourself in a side view mirror, you appears to be smaller. You appears to be smaller, but your view of the field is larger. You can see a larger area is covered in. Such mirror is known as the convex mirror. And the second one, if you got the pain or anything, dental pain, if you go to a dentist, he will use the concave mirror to see the enlarged part of your teeth. The same way, in shaving kits, we can see this concave mirror, and also in makeup kits, you can see this concave mirrors. Actually, it is a classification of the mirrors. In coming classes, we will talk about these things detailedly. First time I'm introducing. Right now we are taking a plain mirror and we are trying to learn about the laws of reflection. And what are the laws of reflection? You have to understand. I think you understood. Light is classified into two, ray optics and physical optics. Here in this session we are talking about the reflection. That means we are following the ray optics. Okay, now we are going to learn about the laws of reflection. I told you, reflection is the phenomenon of light. That is what I said, bouncing back of the light when it incident on a surface. Or simply you can say, the change in path of the light when it incident on a surface. Do remember that. The phenomenon of the reflection take place in a single medium only. Remember, the phenomenon of reflection take place in a single medium only. Then we will see how it happens. And we are learning the laws of reflection. Say it is a plain mirror. Is the mirror? No. Here, if it's silvered at one side, we have to draw lines like this, and it represents a mirror. Say this mirror is AB. Is the mirror. It is the reflecting surface and it is the silvered one. Means what? Here, vertical view, it is the silvered surface and it is the reflecting. Okay, let's say a ray came, ray is traveling in this way and it comes an incident on the surface. Make sure that you have to draw the line straightly. Okay, you have to draw the line straightly, the ray, and it incident at a point on the mirror. Say this point 2. Here, where it incident on, you have to draw a normal. Okay, is the line which is drawn. We call it as the normal. It is let's say the incident ray. And what happens when it incident on surface? Okay, actually it has to move in this way because light travels along the straight line. We call it as rectilinear propagation of the light. Light always travels along the straight lines. Actually it has to move in this way. But because of the obstruction of the mirror, it changes its path and it travels in this way. Okay? Here, it is the path traced by the light ray after it is obstructed by the mirror. Say this one, B. Here in this one, we call OA is incident ray. It is incident ray. And say OB as the reflected ray. Call it as reflected. And ON is the normal drawn to the surface. Now we will define the first law of reflection. The incident ray, this one. The reflected ray, this one. I showed with the arrows. Okay. The incident ray, the reflected ray, and the normal drawn to the surface lies on the same plane. We call it as the first law of reflection. What's the first law? Incident ray, comma, reflected ray, and normal drawn to the surface lies in same plane. Is the first law. And we are going to learn about the second law. Second law can be stated like this. For a regular or a irregular reflection, the sine of the angle of incidence is always equal to the sine of the angle of reflection. Is the angle between the incident ray and normal. Okay. And say it is the angle of incidence. Is the angle between the incident ray and the normal. And here it is the angle of reflection. Angle between normal to reflected ray. It is R. What the second law is? Second law can be stated like this. I already told you. For a regular or irregular, a diffused reflection, angle of incidence, angle of incidence I is equal to the angle of reflection, or broadly we can say angle I is equal to angle R. Is second law. Here it is a regular surface, that's why mathematically we can take it as I is equal to R. That means simply we can say angle I is equal to angle R. But if you take the irregular surface like this, okay, even though it is a irregular surface, angle of incidence is equal to angle of reflection. It happening because if you compare the size of the atom with the wavelength of the light, then wavelength of the light is in the order of the size of the atom. That's why even though the surface is irregular, the angle of incidence is equal to angle of reflection. And you have to remember one thing. When we are talking about the phenomenon of the reflection of the light, and you know that the speed of the light can be had with c is equal to nu lambda. This is the speed of the light, and you learn that the speed of the light is approximately equal to 3 into 10 to the power of 8 meter per second, or you can write it is 3 into 10 to the power of 10 centimeter per second, where nu is the frequency of light. Frequency means number of oscillations per second, and lambda is wavelength. Why I am quoting all these things? It has a regular meaning. What does it mean? Well, the phenomenon of the reflection is taking place. All the physical quantities remains constant. The speed remains as c only. There is no change in speed, and frequency of the light ray remains constant, and also the wavelength. Okay, these are the laws of reflection. First law, the incident ray, the reflected ray, and normal drawn to the surface lies in the same plane or on the same plane. And the second law is for a regular or irregular reflection, angle of incidence is always equal to angle of reflection. We'll go some further in this and we talk about the deviation. I hope you understood up to here. Okay, I said it is the angle of incidence and it is the angle of reflection. Actually, what did happen? When it falls on, it changes its path. The angle in between, this one is known as angle of deviation. That means, okay, it suffered a change, this one. Here you know that the total angle is 180. 180 degree could be equal to I plus R plus angle of deviation. Okay, and angle of deviation is equal to 180 minus I plus R. Okay, and also we'll end that for a regular or irregular reflection, angle I is equal to angle R. Then angle of deviation is equal to 180 minus 2I. Okay, in the problem he will give you angle of incidence on a parade mirror is equal to 30 degree. Then find out the angle of deviation. D is equal to 180 minus 2I. It is 180 minus 2 into 30. It is equal to 180 minus 60, 120 degree. Here you have to find out the direction in which the light get reflected. See the direction. In this way it deflected. It is anti-clockwise direction. Level. First we have to understand what is the object is. Object. Here in everyday life we come across with so many objects. Me, it's an object. But I am non-luminous. And second one is the self-luminous. Means what? The objects or which gives the light. Okay, but here we go somewhat deeply. Okay, anything which is giving light is the object. Okay, when we are studying the ray optics, we come across with two types of objects. I said objects are of two types. Here one is the point-sized object. One is the point-sized object, and second is extended okay. What I said, in ray optics we classify the objects into two. One is the point-sized object and second is the extended object. That means point size, it means what? Its dimensions are very small. Okay, so it's the point from where the rays are emanating like this. Rays are emanating like this. That means rays are going on. It is the point-sized object. And what is the extended object? For example, you take a optical element. Okay, is a source. Here, this one is made of number of point-sized objects. That means number of points. If you take this razor, appears to be like this. If you extend, it might be in this way, and you can show it's like this. The same thing what I drew, I'm drawing there. That is okay. It is the what I mean is an extended object is made of number of point-sized objects. Here it's a point. Generally, when we are going to draw the ray diagrams, most of the time we take the point-sized objects only. Okay, to understand what is the image, previously I said, to form an image of an object, we must know what are the objects and as well as the images. And I think you understood what are the objects. There is the point-sized and extended object. Then after, we are going to learn about the classification. Objects can be further classified into two more categories, and the one is the real object and second is virtual. The second one is virtual. Here indirectly I showed you what is the real object here. It is the real object. It is the object from which the rays appears to be diverging. Is divergent means moving away. I'm not doing anything new. I'm redrawing the diagram. Okay. Rays appears to be diverging is known as the real object. Real object is that from which rays appears to be, ray means light rays appears to be diverging, is the real object. Okay, then what is the virtual object? See this? Imagine rays are coming from a distant object. See this? Okay, they are. I kept a optical element here. Optical element is nothing but a mirror. I kept a mirror here. Then what happens? You may understood. If you extend this, it incident on and as well as it also incident. Make these rays to meet at a particular point. Make these rays to meet at a particular point. This one is known as virtual object. Okay, we call it as the virtual object. Why it is called as? It is simple. If you watch this, you will understand. From the object, it is the real object, not reverse osmosis. It's the real object. Rays appears to be diverging. And watch this. The opposite thing is happening. Rays appears to be converging. rays appears to be converging. Okay, it is known as the virtual object. Here in this way, we can classify the objects as a real object and virtual object. I hope you understood. From an object, the rays appears to be diverging. It is known as the real object. Okay, where rays appears to be converging. It is known as the virtual object. It is a classification. Thereafter, we have to know what is the images. Image is nothing but point of intersection of the rays. Is a point of intersection of the rays. You can understand this thing very easily. I hope you understood this. Okay, and we are going to learn about images now. I said image is the point of intersection of light rays. Again, these images are classified into two types. One is real image and second one is the virtual. It is the virtual image. Okay, images can be classified into two types. One is the real image and second is the virtual image. Okay, what is the real image? See this? I am redrawing the same diagram here. It is the mirror. Okay, rays are coming from a distant object, the incident on, and one more ray. Okay, then what happening here? We make them to meet at a particular point. Then after it is incidentally gone, what happens? We have to follow the laws of reflection here. It is the angle of incidence and this ray get reflected in this way. That means it will move further like this. The same ray, here it incident, get reflected. The two will meet at a particular point. The two will meet at a particular point. This image is known as the real image. That's why I said it is a point of intersection of the incident rays. Okay, point of intersection of the rays actually here. It is the real image. And now we will see what is the virtual image. See now. Take one, what? Optical element, and see, we took a point source here and rays are, the place is insufficient. I will draw here. Okay, I will make somewhat small. I will draw here. It is the optical element. I took a point sized object and you know that it is the real object. Rays are coming from the incident only. Then what happens? They get reflected by following the laws of reflection. Means what? It is the I is the R. The same thing happens here. It is I and it is R. If you extend these rays backward, if you extend these rays, they might meet at a particular point. Okay, here it is known as what? Virtual image. If you watch it carefully, you will understand one thing. A real object, see this, a real object, the same thing I took. A real object forms the virtual image. And see, here the same thing will happen. Okay, a virtual object, it is the virtual object forms the real image. There is a relation between the two. A real object. Now we are going to learn a virtual image, where the image formation and virtual object forms the by a point-sized object. Is the thing you have to come across with. On our class, you learned about. Watch it carefully. I think you understood what is the object and what is the image, and what is the virtual object and virtual image, and as well as real object and virtual image. And also you have learned that what a virtual object can form a real image, and real object can form a virtual image. Okay, now it is the time to formation of images. Okay, let's take an optical element, say it as a mirror. Okay, call it as an optical element. Then locate a point-sized object here. Is a point-sized object. I call it as object. Okay, already I told you point-sized and as well as it is real object. Real objects can diverge the light rays. Take such light ray. Okay. The light ray. One of the light ray we took, it traveled along this way and incident on. And take one more ray. We made it to incident on like this. These are the rays coming out from the object. Then you have to follow the laws of reflection here. What happens now? We have to drop a normal, and we dropped one more normal here perpendicular to the optical element. Let's see, it is the incident ray and it is the incident ray here. After this, what could happen? The incident on, according to laws of reflection, the light rays must get reflected. Okay, this ray reflected like this, and if you watch this light ray reflected in this way. I'm very bad in drawing. Again I am doing the same mistake. Okay, I'm unable to use the scale in proper way. This is the reflected ray. I'm making somewhat darker. Here I did the same. You have to draw a straight line. Okay, rays are, it is a real object diverging after incident on, they change their path. That phenomenon is known as the reflection. What I am doing now, I am extending this ray further. I extended. In the same way, I extended this ray also. Okay. The two will meet at a particular point. We call it as the image. Is the real object and it is virtual image. Already I told you I am very bad in drawing. If I redraw the same thing, it appears to be like this. If I take the scale in a proper way, it might be like this. It is the image. If you watch it carefully, you will understand, okay, the properties of image formed by a point-sized object. Okay, it is the object and we get the same, it is the image. Join the two lines, that means join the object and image. Okay, look at a point, some x here. If you measure in a proper way, you will get Ox is equal to, actually I have tried, it has XO. Why did I write it is, you will understand, and it is equal to Xi. Okay, XO is what? It is the distance of the object from the mirror. Object distance is equal to image distance. That's why what's happening, if you stand in front of a plane mirror, you appears to be at the same distance inside the mirror. Just imagine you are moving towards the mirror with a speed of 2 meters per second, then what could be the speed of your image and what is the relative velocity of the object with respect to the image? Just think. Here is the object distance and it is the image distance. In the same way, if it is moving towards this, what velocity it has, the image also has the same velocity. Understanding me? And also the size of the object is equal to size of the image. That means what? We'll learn a new word here. In later section you will understand those things, magnification. Here the magnification formed by a plane mirror is always equal to 1 because image distance is equal to object distance. We'll learn about this in later videos. These are the image characteristics formed by a object, that is point-sized object. I hope you understood how to draw the image for a point-sized object. Here it is the plane surface we drew the image, and what I am doing now, I am taking a curved surface. Let's say it's a curved surface. Okay, this surface is known as the convex surface. Then imagine a light ray came and incident on like this. What happens? Nothing will happen. It will change its path. The light ray changes its path. Actually, it has to move along this way. But this mirror, we call it as the convex mirror. What it did, it reflected the light. Okay, here angle of incidence is equal to 0 because the light rays traveling normal to this plane. The same thing, angle of reflection, it is obviously 180. Here it came here and changed path. In the same way, now think, a ray came and incident on like this. And what happens here? The same thing will happen. It will move in this way. It is the angle of incidence and it is angle of reflection. Okay? It is the application of what? Laws of reflection here. In the same way, if you take a concave surface, it is a concave. Keep a point-sized object here. I put and I drew a normal. And already you learned that if the ray falls in this way, it gets reflected. But ray is coming from a distant object. It's a point-sized object, incident on. And what happens to this? It reflects in this way. Okay, it is the image formation by a point-sized object. Later you will understand what could be the image position and what are the characteristics when the ray incident on any surface. Then after we will learn about the image formation by an extended object. The same thing you have to follow here. Let's say it is the optical element. We named it as the mirror. And we have to take an extended object. I told you, extended object is made of number of point-sized objects. That means each point behaves like a object only. Imagine that one ray, just one. Okay, the same thing will happen. We followed the laws of reflection. It get reflected, and also if you follow the laws of reflection here, it is the angle of incidence and it is the reflection. The same thing will happen here, incidence and reflection. Okay, draw a line, extend it. Okay, if I extend this ray and this, there appears to be meeting at a particular point. It is the image formation by extended object. It also follows the same rules. What point-sized object followed? Object distance is equal to image distance and the magnification is same. Okay, it is about real objects and real images, virtual objects and as well as the virtual image. And also you have learned that